Hi, I'm Nils Gauthier. I'm a new junior group leader in IFOM in Milan, and my focus interest is on the Mechano-Oncology, or if to take it more simple, the role of physical force during tumor progression. Then my research interests are basically focused on an important key point in biology. It's the interaction with the plasma membrane and the actin cytoskeleton. And it's mediated by numerous kinases, phosphatase, and a lot of different proteins and lipids. And my research focus is really not especially on those molecules, but rather on the physical forces that rise from this interaction and how those physical forces are implicated in biological events. And specifically, I have three axes of research. Two axes are focused on not the tumor themselves, but the stroma, meaning the environment surrounding the tumor, with first the fibroblasts, which are the cells that are surround and build the matrices around tumor in our entire body. Second, the phagocytosis, which is this innate immune response that is responsible for bacteria clearing, cancer cell clearing, and also the phagocytic cells are implicated in tumor infiltration. And as such, it's an interesting subject to study, because by this way, we can maybe tackle the function of those phagocytic cells to understand how they favor or may repress tumor progression. And finally, I'm also interested in a very specific cancer, the glioblastoma. Why this cancer? Because it's a cancer that has a very fast progressing process. It migrates rapidly in the brain. It kills the patient between 6 months and a year and a half max. And as such, it's an interesting, I will say not interesting cancer, but very interesting and promising subject, because with the axis that I'm taking, meaning biophysical tool and mechanical forces, we may access to properties of this cancer that otherwise will be missed or left on the side of the road, and that may be in fact tremendous for the benefit of the patient down the road. Then the connection between the line of research that I do and cancer are multiples, but what I think is really interesting is the new approach, because all what has been done on cancer, I mean a lot of studies have been on the genomic aspect, and we are lacking knowledge on the physical aspect and on the mechanical force around the tumors. In fact, it was mentioned by Giorgio Citta, one of the early detection of cancer is palpation. And by palpation, you feel that you have a mass, a tumor mass, that seems to be stiffer than the surrounding tissue. Then how you identify this tumor? Just by the physical aspect of this tumor. Then maybe by tackling and knowing what are those physical aspects and the mechanical forces surrounding tumor, we may be able to have better understanding and better way to cure this cancer. And I think that's where the link is the most important link. And to get back to the three subjects that I'm working on, the two first, meaning the stroma aspect is very promising. Also because what we have, most of the world is focusing on the tumor cells. And we are trying to kill the tumor cells. But the tumor cells are extremely heterogeneous, they become resistant to treatment, and so on. Then maybe one better way to treat cancer is to customize the cells that surround the tumor in order to help those cells to kill or restrain this tumor. And rather than the chemical or biochemical cue, I'm trying to focus on the physical aspect, and maybe we will have new way and new therapeutic way to down the road of this research. Then the future perspectives in the field are pretty much unknown, but with huge potential. Because it's a sort of gamble that we have, then we are thinking that since cancer is a hard disease to treat, and the progress are slow and relatively difficult, we think that maybe taking this new approach regarding the mechanical force surrounding tumor could be of tremendous interest. And down the road, what we are thinking is really like by customizing those mechanical properties around the tumor, and particularly by not tackling directly the tumor, by tackling the surrounding tissues like the fibroblasts or the immune cell that surround the tumor, we may be able to change the behavior of the body and help the body to literally either remove the tumor itself, which will be a fantastic achievement for the patient, or at least stop the progression of the tumor. And that's, for example, for the brain cancer that we're trying to understand, because by stopping and transforming a glioblastoma to a local tumor rather than a spreading tumor, surgery could be more efficient to remove, and you have less chance for recurrence in the other part of the brain.